or answered any questions. And user histories then become trajectories in action space. So if you're a user, you kind of exist on the site, then you might ask, answer a couple questions, then ask one, then ask another, then answer another, and so on and so on. And you can see users as basically just kind of flying through this space. Now, what is a badge? A badge is simply now a subset of action space. And so the way badges are designed is saying, okay, if you take, for example, more than 6 A1 actions, I'm going to give you a badge. As soon as, yeah, go ahead.
In reality, it'll be way more than 2 dimensions, right?
That's right. Yeah. It's just so I can just put it on the screen. Yeah. Okay, so badge is a monotonic subset of action space. Monotonic just means as soon as you win a badge, you can know it can never lose it. And it has some value v sub b. Okay. This value can be different for different users. Now we're just looking at the action space with respect to a single user. So that one user has some value for winning a badge. Okay, so how does the user actually move through space? We're going to assume that at every step, they're going to choose a probability distribution, P sub A, where A is the action cell that they're in, to draw the next action from. Okay, so they're not going to say, if I'm ever in, for example, if I'm ever at the origin, I'm always going to take one action. They're instead going to mix over a distribution of actions. Okay, and they also exit from the site with probability 1 minus theta. All right. So this becomes now a direction in action space. And users also have preferences for actions. So the way we model this is that they have a preferred distribution over actions. So absent everything else, they would just choose to go in a certain direction in space. So here I'm going to represent that with this purple arrow. Now, if the user, for whatever reason, picks a probability distribution in a certain cell that is different from their preferred direction, then they incur some penalty because they always want to choose the actions that they like to mix over. And if you kind of mix over actions differently than your preferred mix, then you're going to incur some penalty. Here we're just going to say it's the L2 squared loss function, but it could be anything with very simple properties that I won't get into. Okay, so that's it. Those are
just the least squares distance from their preferred trajectory.
Yeah, exactly. Exactly. Should just be a distance, exactly. So the cost is 0 if and only if they choose their preferred mix over actions, and it increases as the distance from their preferred actions gets larger. Okay. Okay, so that is basically everything in the model. Now the user now has a utility function, which is composed of 3 parts. Okay, 2 are very simple, and the third isn't that bad either. The first is they always have the value from the badges they've already won, so they just keep getting value. The second is the cost that I just talked about for deviating from their preferred action direction P. And then the third is going to be a recursive utility, which is just my expected utility of being in the next state. Okay, so I choose some direction to move in, and that distribution over directions that I move in, I have utility for being in every one of those states that I could possibly go to, and I'm going to just get that expected utility for being in the next state. Okay? Any questions about that? All right. So given this very simple model, the user is then faced with an optimization problem. I want to pick directions to move in, given every cell that I could be in, which is what we call a policy, to maximize my utility for being on the site, which is just the utility for being in the origin. Okay. So pictorially, that looks like this. It's saying I could be in all of these different cells. What direction should I move in every one of these cells to maximize my utility? I get utility for 2 things, well, really from 3 things. 1, from having badges. 1, I lose utility for not doing what I naturally want to do. And 3, I get utility for being in the future. Okay, so basically we have a trade-off here between I don't want to deviate from what I naturally want to do, but I also want to move badges. So how does this trade-off play out? So we're going to do a very simple example. So we have this two-dimensional space, and we have 1 badge. That badge boundary is that dotted, that dashed line there, where the badge criteria is just denoting this very simple subset, which is if you take 7 or more A1 actions, then it'll give you a badge. Okay. Okay, so yeah, question.
So it decreases if you do something you don't want to do, but it doesn't increase if you do something you prefer to do.
Yeah, that's right.
Game because of just doing whatever.
Yeah, exactly, yeah. I mean, you could add some like constant onto that loss function that I talked about. But the one that I showed basically is, yeah, the maximum it gets is 0. Yeah. Any other questions about this setup? Okay. Okay, so this actually is a MDP. It's a Markov decision process. But it's a very difficult one because we have an infinite, even this very simple example, we have an infinite dimensional space, action space, and there's a continuum of actions in every cell. So you can choose a distribution member for every cell. So typical MDP techniques will not work in this setting, but we have a structure that we can use to solve this problem. So we have to make a couple observations about our setting. So first of all, past the badge boundary, there's no longer any incentive to deviate from my preferred mix over actions, right? I've already won every badge there is to win. I might as well just do what I want to do now. So past the badge boundary, I'm always going to just choose my purple direction, my preferred direction.
I have a question.
Yes?
What if there are multiple badges? You've only won one badge.
That's right. This is a very simple example. I'll get to multiple soon. Yeah. Okay, so past the badge boundary, I just choose what I always do what I naturally want to do. Now, before the badge boundary now, I need to select my directions to move in to maximize my expected utility. Now, the second observation is that basically in this example, all of the cells in the same column have the same expected utility, because all that matters is choosing directions that are as close as possible to my preferred direction and the badge boundary, which in this case is only on the A1 axis. So basically all that matters is your distance along the A1 axis. Wherever you are on A2 doesn't really matter. Okay. So basically we can collapse this particular problem into one dimension because it's a one-dimensional problem. So that means is past the badge boundary, we already know how to solve it. And then we have this one-dimensional problem, which is basically, given that I have this green cell, how do I calculate what I should do with the red cell? Now, this turns out to be an optimization problem. You can, if you write it down straight up, you can't solve it, but basically we can transform this into an easily solvable single variable optimization problem. I won't go into that. Just trust me on this. So basically the problem is one-dimensional. Past the badge boundary, we just do what we always want to do. And then given a future cell, I can use this kind of single variable optimization problem to just figure out my optimal direction. So near the badge boundary, I'm not going to do what I always want to do. I'm actually going to deviate more towards taking A1 action, because that increases the likelihood that I actually get past the boundary and therefore get value from badges. And then a little bit further away, I'll do something similar, but not quite as much, and then so on and so on. Okay, so that's one dimension. How do I go to multiple badges? So say, for example, you have one badge on every dimension. This is like kind of the next most difficult problem. Again, we can make some very similar tricks. Okay, so past the badge boundaries, both of them now. Once you're past all the badges, you always never have an incentive to deviate. So therefore, you can always figure out very easily what you should do past the badge boundaries. Just do what your natural predisposition is. Now, past one badge boundary but not the other, this turns out to be the one-dimensional case, right? So, for example, in the top left, we just solve the one-dimensional problem that I just talked about. Similarly, for the other case, if you have past one badge boundary but not the other, then you simply have the problem where you have one badge on one dimension. You solve it as we just described. Now you're left with a kind of finite problem where the future you've already calculated, so you can always figure out what your optimal strategy is using a very similar trick that I described before. So you can just solve this directly by using dynamic programming. You just fill in the table starting from the top right and recursing all the way to the left, and then going down again, starting on the right, going down all the way to the left. Okay. All right, so this is the output of our model. So this is just an example that I showed. But here's a real run. So say I have some action, some badge, sorry, on one of the dimensions, and another badge on the second dimension. What is the output of my model? So now this model is saying, given this user cares about these badges, so if there's a v sub b for the first badge and some other v sub b for the second badge, what will their behavior be? And these arrows are basically describing the optimal direction that they should choose given every point in the action space. Okay, so this model makes several predictions. I'm going to walk through all of them. One, like we've already discussed, past badges, there's an immediate reset. There's no kind of like learning. It's not like this badge has taught me that I like this action, so I'm going to maybe change my preferred mix now, although this model could capture that. Currently, we're just saying past badges, there's an immediate reset to what you naturally want to do. Far away from the badges, there's no strong pull. So basically, far away from the badges looks very similar to when you already passed them. When goals are super far away, you're not strongly motivated to achieve them. But close to badge boundaries, we see two things. One is steering. So the direction of the arrows is actually diverting towards the badge boundary, right? So this is basically like, almost looks like the badges are sort of magnets, and the human behavior is like these iron filings. It's like lining up with these magnets. Secondly, we also see more engagement. So remember I said we have n+1 actions. Here I'm showing 2 on-site actions. And we're saying there's a third, which is basically doing anything else but taking actions on-site. Now, so these arrows, so the space is actually a three-dimensional space, and I'm still showing the projection of the arrows onto this 2-dimensional kind of site space. So basically, the length of the arrow here is basically corresponding to how much behavior I'm doing on-site. So you can see early on, in like near the origin, for example, the arrows are quite short. That's because there's a lot of load on the off-site action. But when you get close to the badge boundary, the arrows get longer, which means there's less load on the off-site action. So people actually spend more time on-site, is what this model says, as you get close to the badge boundary. There's also this very natural acceleration towards the badge boundary, which we didn't build into our model at all, right? So you say, as you get closer and closer to the badge, you get more and more turned towards this badge boundary. Yes.
I think this is probably going to be addressed later, but I'd like to ask how you assess the validity of your model to real-world data.
Yeah, for sure. So I can do that right now.
Okay.
Yeah. Yeah. Okay, so just to summarize this model, right? So this is a very simplified model of the world. We're just basically the ingredients of the model were that their kind of social systems are basically captured with this action space idea, and users travel through the action spaces as they take actions on site. Badges then become simply subsets of the space, and our model makes 4 main predictions that I just walked through. Okay, so to address this question, how do we validate this model? How do we know that it's true at all? Basically, the strategy is going to be to validate these models' predictions on real-world data. What's that data? That's one we already talked about. Stack Overflow, which is this programming-related question-answering site. Like I said, makes heavy use of badges. This is actually the original motivation for doing this work. I'm going to look at 2 badges in particular. 2 of them, so one of them is the electorate badge. This is, you win this badge when a user votes on 600 questions. So I actually asked the founders of Stack Overflow why they had this weird badge, because it just seems so unlikely that someone would ever vote on 600 questions. And that was really the point. They were saying, you know, we found a lot of social value, like there was a lot of value when people voted on questions because it helped us sift through like what were the high quality questions, what were the low quality questions. There's a lot of identical questions. You're not really sure which one to show to people when they ask for something. But people weren't voting on questions. They were voting on answers. They were saying, this is a good answer, but so a lot of times they would have good answers on kind of poor questions. So they wanted to incentivize people to vote on questions. So they did that with the use of badges. Similarly, there's a civic duty badge, which is one when a user just votes 300 times in general. They want to incentivize people to start voting, instead of just like going to the page, taking the correct answer, and just leaving, which I've done, and I'm sure everyone here has done too. Okay, so let's just go straight to the data. This is the electorate badge, the first one. And let me just explain what's going on here. So on the x-axis, I'm looking at time. So basically, I'm taking everyone who ever won this badge. I'm going to axis aligning them such that x equals 0 is the day they won the electorate badge. And the y-axis is just a count of actions they were taking per day. Okay, so for example, minus 20 is 20 days before they won the badge, and plus 20 is 20 days after they won this badge. So what do we see? First of all, past the badge, there is an immediate reset to what they were doing before, right? There's no kind of gradual drop off. It's like really striking, kind of falling off a cliff. So this green curve is votes on questions. And remember, this badge is incentivizing voting on questions. So sure enough, right as soon as you pass this badge, you get an immediate reset to what you were doing roughly 40, 50 days before you started getting close. Again, 40, 50 days, like far from the badge, there was no strong pull. Basically, you were doing what you were always doing, and you were doing what then you would go back to doing after you won the badge. So it's not a very incentivizing thing when you're far away from it. Close to the boundary, we see steering, definitely, because people are voting a lot more on questions than they would normally. And there's more engagement overall. If you just sum these curves up, people are simply taking more actions per day than they usually are, right? You have, there's no kind of like negative effect on the other actions, maybe except for answering vote a little bit. And also there's this acceleration towards the badge boundary. It's not like a step function. It's not like one day you decide to just go for it on this badge and do like 20 actions a day until you get it. You kind of get more and more pulled towards the badge boundary as you get closer and closer to it. Okay, so actually this is related to an old hypothesis, almost 100 years old now, which is the original finding was that rats in a maze run faster as they near the food box.
Even if like there's walls right between them, and getting around those walls would mean going all the way.
Yeah, exactly. That's right. So our setting is kind of a multi-dimensional version of this. Models that try and figure out why the goal gradient hypothesis behavior kind of actually happens. They always build in the acceleration. They always say, okay, we assume the accelerates. Basically, they're assuming what they want to show. And our model also has a prediction for post-reward behavior. So I just wanted to point out the connections to this old literature. There's very similar results on the other badge that we studied. I won't go through it, but basically you can see this badge is now incentivizing two types of behavior. And both of those behaviors kind of climb up to their peak around day 0 or day -1, and then they kind of fall quickly back off. Okay, so we're saying that this kind of real world matching with data and these predictions lining up is a validation of our model. Not saying our model is exactly how things work, but it's simple and simple enough and seems to match up with reality enough that we can then use this model to try and figure out how to optimally design badges. Okay. So the design question here is, how should I design my badges? How should I change the criteria so that I maximally elicit behavior from my users? So how should I place my badges in action space? How should I move those kind of boundaries around such that the kind of incentivization is greatest or most closely matches the desired behavior that I want? Yeah?
Now that I think about it, I was wondering how this model would reflect badges that don't require actions taken on the part of the user. For example, I say, ask a question that receives over so many positive votes.
Yeah, for sure. Yeah, so that's a really interesting question. So this model doesn't have so much to say about that. This is more about threshold badges, which is actually a big fraction of badges on these sites. But yeah, the more kind of award type badges, which is like, I'm going to give you an award or a badge for a particularly high quality piece of work. That's harder to say.
Okay.
Yeah, definitely agree. Any other questions? Someone had their hand up? No? Okay. No. All right. Great. Okay. So how should I place badges? This is maybe the easiest example. If I have one badge and I want to maximize the actions on a particular dimension, where should I put that badge? So this is a particular, exactly where you should put the badge always depends on the parameters in your question, like how much users value the badge and so on and so on. But let's say everyone has a fixed value for a badge, and I'm going to choose one of the dimensions to put a badge on. The only thing I can do is vary the threshold that at which I'm gonna give you the badge. And you can see it varies a lot actually. So on the x-axis is like where you're placing a badge. So x equals 50 would mean I'm gonna put this badge at 50 actions. And then the y-axis is what we call the yield, which is exactly this thing that I want to maximize. It's the fraction of actions that are on that dimension, given that people have this valuation for the badge. So first of all, where you place it actually matters a lot in the parameters that I've chosen here. And secondly, maybe kind of obviously, but it still falls out of the model, is the optimal badge placement is somewhere in the middle, right? You don't want to put it too early on because then it's super effective, but only for a very short amount of time. Then people immediately drop back down. You also don't want to put it too far out. If you have like a Nobel Prize badge on this dimension, then no one's going to be incentivized because no one's ever going to be close to it. So you want to put it somewhere in the middle. Okay, what if I have two badges? And here I want to incentivize, again, actions on a single dimension. This is kind of cool actually. So this is I have two badges now and I can choose the badge placement for the first one and the second one. Where should I put them in concert with each other such that the combination of these two badges has the greatest effect? The color now is the yield, is the fraction of actions that are on that dimension that I want to maximize. And the x-axis is where I put the first badge, and the y-axis is where I put the second badge. You can see, again, it varies a lot. And then there's some design principles that emerge now from this framework that I think are not what I would have guessed. The first is that two small badges are better than a big one. So in particular, the maximum here is not on the diagonal. So you can basically put them together if you want, put them at the same spot. And you might have thought that maybe they have some kind of like super additive effects. It turns out here they don't, at least in our model they don't. And here the designer should move badges approximately evenly apart for maximum effect. And if you actually take this principle kind of and iterate it, that means if you have this ginormous badge, it's always better to break it up into two. Then you can, of course, recurse on this two small badges and say, well, it's better to have 4 badges than 2, and so on and so on. And so there's basically saying that, in an ideal setting, you should have a continuum of badges. Of course, in real systems, there's probably some cognitive load effects that people can't keep all these badges in their minds, so they can't be incentivized by 1 million badges. But the examples that I showed you early on, there actually were a lot of badges, right? So Stack Overflow has literally hundreds of badges. Khan Academy has hundreds of badges per type. So I think they're actually taking this design principle seriously and having lots of little small badges as opposed to a few big ones. Yes?
Yeah. Would you say the more badges you have, there's kind of a decrease in value associated with those
That's
badges?
an interesting question. So if I have a bunch of badges already, I care less about each new one?
Yeah.
Yeah, that's possible. Yeah. So just generally speaking, the question of what value users ascribe to badges, I think is a very difficult one to answer.
Okay.
So I don't know about that. I don't know about that. I should also mention that this framework, all we're assuming is that you're getting some award for some pre-specified number of actions. And we're applying it to badges, but it could actually be used in other settings as well. So you can imagine using this applied very naturally, like airline rewards or rewards programs more generally. And there, the value question is a lot easier. It's just saying, I'm literally going to give you a free coffee or whatever, and the value for that's pretty fixed.
Okay.
But yeah, the social value of badges I think is more tricky. Yeah. Okay, and we can ask other questions as well. So we have a bunch of design principles that we got from our model here, but I'll just finish with one last one. And this is, let's say you have 2 badges with a fixed total value. So I have a fixed amount of kind of social capital to give out with badges. How should I split them according to the 2? Should I split them one really tiny one and one big one, or should I have 2 big ones? And it turns out that the optimal yield you can get is if you split them roughly equally. So if you can make badges roughly equal to each other, that's better than having super tiny ones and super big ones. Okay, one last kind of interesting thought experiment that we did was it's not even clear what you can possibly elicit with badges. So we're saying, say you have two fixed value badges. Now it doesn't really matter what the values are. What is like the design space in which I'm operating? What is the feasible region of like action distributions that you can elicit with badges? So here, an XY point would be, can I get people to have a yield of 30% on the x-axis dimension and 20% on the y-axis dimension with any combination of two badges? And I'm going to fill that in if I can. I'm not going to fill it in if I can't. What does this design space look like? So it turns out for these two particular badges, it looks like this. It's a very kind of interesting, complicated heart shape. The blue points that I've drawn here are things you can elicit with two badges on the same action. So of course, they're closest. The two A1 badges are closest to eliciting a lot of A1 actions and not very many A2 actions. The red are the vice versa. So if you have two badges on the A2 dimension, you can elicit a lot of A2 stuff. And of course, if you have one on each dimension, you can elicit somewhere in the middle. Now, what's kind of interesting is that this region is like non-convex. It's like very unclear how you could have predicted this before you had the model work.
A leaf.
Yeah, it's like a leaf or something. Yeah, exactly. It's almost like a Rorschach test. Okay, so to summarize this part of the talk, we introduce a model of user behavior in the presence of badges. So that this model predicts that users will steer between actions and engage more on site when they get close to the badge boundary. Validated this against real-world data and then investigated how you should design badges. Okay, so in the last part of the talk, I just want to talk about implementing this in practice. And we're curious about the following question, which is, how much really do badges increase engagement? We have this model kind of saying they do, matches up with real-world data, kind of predicting that they will increase engagement near badge boundaries. But if you took a site and just added a badge system to it, does it really increase engagement? So we had the fortune of badgifying Coursera's machine learning class. Coursera actually approached us and said, we really want the forums to be more active, so can you do that with badges? And so the experimental setup here is that they ran two classes before they asked us, and these two classes were ML1 and ML2, and then they asked us to badgify the forums on ML3. You can see some summary stats of these classes here. So the kind of concrete question here was, can you design and implement a badge system to increase forum engagement on ML3? And so we did so. So we came up with a badge system kind of following a lot of the design principles that I talked about. These are all the badges. I'm not going to go through all of them. We have kind of different types of badges. So these like great achievement badges that someone asked about before, which is like, badges that are awarded for taking a certain for actually giving like a high quality answer or starting a high quality thread. But the badges that we're most interested in were these threshold badges at the very top. So these first two badges. And these were for incentivizing voting, so voting on questions and threads. And also the reader badge, which was incentivizing just reading threads. So just please be active on the forums. Importantly, we didn't badgify reply, like number of replies or number of threads, because we didn't want to encourage spam. And so very simply, we had this question: did the badges have any effect at all? And this is an observational study now, because we didn't split the class into two and like randomly put some users in one of the classes and none in the other. All we can do is do an observational study between ML3 and the first two runs of machine learning, just to give that caveat. And so here's what the distribution of engagement looks like. So these are log plots of the distribution of actions, both on voting and on reading. So the green and blue curves are ML1 and ML2, and the red curve is ML3. Now, this is a CCDF, so basically an XY point here. So for example, in ML1 and ML2, this is saying that roughly, let's see, actually, so these are due 10. Okay, so let's, any point here will say, what is the fraction of people who took X amount of votes or more? So for example, on ML1, there was like 20% of users who did 10 or more votes during the entire class. Now, what we found was that there was actually a 5 times increase in the likelihood of getting to 100 votes or 100 reads on both of these actions. So these distributions, although they look maybe close, these are CCDFs on log-log plots. So any gap between these curves is actually pretty huge. And the ML1 and ML2 were almost identical, and then ML3 was just kind of like pushed way out. So the tails got pushed way out on the ML3 class. This is on voting and reading. These are the actions that we badgified. And we compare it to actions that we didn't badgify. So for example, number of posts and number of comments, the distributions are basically overlapping. So on actions that we didn't badgify, there's basically no qualitative difference. Right, so just to summarize, on the dimensions that we put out that we wanted to encourage increase, we got a 5-fold increase in engagement. And on the dimensions that we left alone, there was basically no difference. And I think this also speaks to what people have used these badges for and why they're kind of so exciting for site designers, which is that engagement can be increased in targeted ways. So it's not just like this one thing that might change your entire ecosystem in ways you can't predict. It's like saying, I want to do this very particular thing, so you can specify a very particular badge for it. Okay, in the last part of the talk, I'll talk about this randomized experiment we ran, which is trying to figure out where badges actually get this incentive power from. So what gives badges their power? What we did here was maybe perhaps the most directly relevant thing to the work that you guys do in this room. And we did a controlled experiment where we varied the presentation of badges to the users. So we had the same badge system, everyone could win the same badges, but people in different groups saw the badges in different ways.
A/B testing.
Basically, yeah. So we compared different badge presentations and we measured which users it seemed to have the strongest effects on. Right, so we did an A/B test on 3 different dimensions. We had badges shown in like a top byline, badges shown in threads, and then we had something called a badge ladder. And we did the simplest possible thing. We just had a 2x2x2 factorial design for these 3 parallel experiments. So the first experiment was this top badge byline. So we had a header and all possible pages on the MOOC. Basically, you have your name in the control group, which is what people saw already. And then in the treatment, we just inserted this summary of how many badges you had won personally. So this is basically kind of associating badges with your own identity on the site. The second experiment was basically associating badges with other people's identities on the site. So whenever you saw someone's name on the forum, they had their badges beside them. You didn't see the ones beside your own name. So the control was just who wrote the post and how many days ago they wrote it, and the treatment was the same thing, except again we're adding in this little summary of badges. The third one was what we call a badge ladder. So when you went to someone's profile page, either your own or someone else's, you could see basically the badges they'd won or the badges that you'd won, and then the treatment was saying, okay, these are the badges that you have won, but we grade out all the other ones. And basically, you could see how far you were from the next badge. So on every dimension, we had 4 badges: bronze, silver, gold, and diamond. And if you'd won, for example, the bronze badge on a certain dimension, you could see how far you were from the next one. And so the results, actually, all of them were somewhat significant. We didn't have tons of users. We didn't have a lot of power. But the badge ladder variant was the strongest one. So it turned out that just explicit goal setting here helped more than increasing the social visibility of badges. But I think the most important thing is that varying the saliency of badges actually had an effect on how powerful they were. Okay, so just to summarize the entire talk, so we constructed a model of user behavior in the presence of badges, verified it against empirical data, and then this last part of the talk, we had a chance to deploy it in a real-world setting and saw that it had these targeted effects that we wanted. And finally, we ran this randomized experiment and found that varying the saliency of a badge had kind of strong effects on how much the badges affected people. So thank you very much. I think we have a little bit of questions. Yes?
Do you think badges work more because it's a signal to yourself or it's a signal to others?
Good question. I think the last experiment showed that just making the kind of goal more visible to yourself was more powerful in this setting, at least, than like making it more visible to other people. So they kind of act as goals and like social power. So I think, yeah, it's a good question. I think it's both, really, but whether it's more on one or more than the other probably depends on the setting. Yeah. Yes.
So I remember there was another question from the audience about having tangible rewards instead of just bragging rights rewards for badges.
Yeah.
Well, I think that would also add another dimension, which is the possibility of abuse of badges if the tangible rewards are of certain value, then there might be motivation for people to abuse the badge system in order to get those rewards.
Yeah, for sure. So one thing definitely that you should be worried about if you're designing any kind of incentives, including badges, is whether, especially these kinds of badges which are just on pure numbers of actions, you want to like incentivize spam. So we had to check for on Stack Overflow if the quality in your actions varied as you were approaching the boundary or not.
Yeah.
And it turned out it didn't actually. So it seemed like there were no negative effects in Stack Overflow. So they were like designed well enough to not elicit bad behavior, but it's definitely an issue. So like I think they have more powerful, the more stuff you, like the more value you explicitly ascribe to a badge, the more risk there is for like kind of bad behavior around it.
I mean, if you take certain video games like Call of Duty, where people start abusing them because, hey, badges don't just give you bragging rights, they give you better things.
Yeah, that's right. Yeah. That was one thing I wanted to mention actually, was the badges that we studied here were explicitly bragging rights. So on Stack Overflow, like if you get more rep score, then you can actually get like different, you get like more power on the site. But that has nothing to do with badges. So yeah, there was just purely like bragging rights on this stuff.
Okay.
Yeah. Yes.
I'm curious if your research touched on what types of users the badging systems would tend to help, and if there was sort of any demographic.
Right. So, I mean, demographics is difficult in our settings. We don't really know much about Stack Overflow users. But we did find that there was a larger effect on more active users, which is maybe what you'd expect, but that was definitely one thing that was very strong. It's like, if you have a badge system, it's more likely going to affect the people who are already most engaged on your site. And Coursera was similar. Like the engagement effects were strongest in the tails. So like I think the way that we present our results is this 5 times increase, which is quite large. But in the tail, right? People 5 times more likely to get to 100 votes or 100 reads, which was a lot on the forums. So yeah, I think it's more likely to impact, at least threshold badges are more likely to impact already engaged users. There have been separate studies actually that study other effects of badges. So like certain badges on Stack Overflow and other sites are more explicitly designed to very new users. So it turns out that there's huge effects in whether you retain users beyond like the first day, depending on the very first interaction. So if you have like a good, like nice first touch, then it's like your users are more likely to stay, for 3 months, a year. It has a big effect. And so places use badges for that often. It's like, congratulations on like coming to our site, basically, or like congratulations for taking your first action. And those things, we couldn't study those because there's just like a threshold of 1. But it turns out that those had huge effects on the new user. So basically the opposite end. So like, I think big thresholds like 50 or 100 are clearly going to affect only the people who are ever going to get close to those numbers. But you can also have an effect on your brand new users using badges as well. I didn't cover that, but other people have studied that. Yeah.
So the model prediction of like the sharp reset once you get the badge works well.
Yeah.
For like especially for the two you showed because you don't learn anything about voting by voting 600 times.
I mean, potentially you could say like, yeah, I mean, in some world, like, voting on particularly good questions might, have some benefit.
Yeah.
Yeah, maybe it didn't for those users, but I wouldn't say it was necessarily had to happen, but I agree with your interpretation of what did happen.
Yeah. You mentioned I think that there might be a way to extend it to like capture maybe like they get more used to writing questions by like doing a lot of question actions or something.
Yeah, exactly. Right.
Can you talk a bit about that, or did you not?
Like getting used to voting on questions. Yeah, I mean, we just didn't observe it. Yeah,
Okay.
It was basically just like went back down to flat line. Like it wasn't a negative effect. It didn't go down to like something below what their usual level was. It just went back to the usual level. So I think, at least what in the data that we looked at, it was basically like a purely additive thing. Like if you took this flat line of people acting around 600 votes on questions, if you didn't have a badge, and you do add that badge, it just looks like you add this big like mountain of activity, like in the 2 or 3 weeks leading up to it, but you don't like subtract anything, and you also don't add anything anywhere else.
Okay.
Yeah.
I'm curious if there could be some inequality richer effect behind that. Because if you already are reaching as many badges and you're posting another answer, you're more likely to be voted as a good answer compared to the other answer you use.
Yeah, I mean, it's not explicitly built in. It's possible. That would probably affect more like other types of badges that we did study, like the non-threshold badges, because if you just have a threshold, there's a very explicit rule for how you win the badge. So there's really no like richer effects there. There's maybe get richer effects in the votes that you get. So there's badges like contributing an answer that gets at least 100 votes or something. That's not what we studied, but there may be some get richer effects there. But I think for just a threshold, just like voting on a question 600 times, like there's no reason why someone with a ton of badges would do any better at that than someone
It's a
else.
sequence of badges and you already have few. It will incentivize people to vote for your answer probably more than
Yeah. So the badges where it's like people are voting on you and you get a badge for that, I totally agree. Yeah, it's just not the type of badge that we study.
Okay.
Yeah. Anything else? All right. Oh yeah.
Oh, sorry. I wonder what if getting badges can have more cost. Like, take my research as like live streaming as an example. Like those people who keep the streamers, they kind of have to like spend money on that and get badges. So
I see.
will that influence the result? Like,
So what exactly is going on there? So is it the streamers getting badges or the watchers?
the viewers.
The viewers are getting badges.
They
Okay,
keep
yeah.
the streamers, and so they spend money, but when
Yeah.
they reach certain threshold, they earn some badges.
Yeah, right.
So for that case, they have to spend money.
Spend money, yeah, exactly.
So the
Yeah.
cost is.
Yeah, right. So I think we did capture that in our model because I think if you remember, as you get closer and closer to the badge boundary, you're not only taking the incentivized actions more, but you're also just spending more time on the site. And so in that setting, you might say they're not spending their money on something else; they're spending it on the badge dimension essentially to win their badge. So
How about if the badges get harder and harder to get the closer you get to the boundary?
that maybe right. Like, ultimately, like chew the draw the carrot away, from
Yes.
someone as you get closer and closer.
Because of, as in maybe the difficulty versus space function is non-linear.
Yeah, that's true. I think that would be a smart idea. Yeah. Great. Okay. Thank you very much.